I think our latest video is actually doing better now on TikTok. I kind of took a hiatus from posting short form content on TikTok because I was just very busy with streaming, but recently we've been doing okay. Oh yeah, nice. Okay, so my first return back, which was inverse trig functions, this only got 2,800 views. This is getting 5,600, and it only came out yesterday. Nice. Love that. Hey, what do people say? Spin that shit. Thank you, H. I had a lecture on this today, and it made more sense. Nice. Yeah, okay, cool. Algorithm's working. Nice, nice, nice. What's up, lad?
My man.
Okay. I have the second part of this Tuma almost done. There are 4 parts I need to release for that video. It's a lot. Alright, let's get all the chats running. There is TikTok. There's YouTube Shorts. Alright, let's see, Haunted. What'd you submit to us? What do we got? Hi, I'm Greg from Compton Flight School. What's up, dude? What's up, Greg? Yeah, that was super cool. There's this nonprofit. Here, I'll shout you guys out real quick before I start doing homework questions. Called Fly Compton. I met the president or CEO on a boat party in like December. But they're really cool. This is an organization that like they teach kids about becoming a pilot and what it's like to. I think they even get their pilot's license because they get like enough hours if they do like all through high school and stuff. So it's really cool. And I went to their kind of. I guess it was like they have a once a month like big day where all the kids get to go on the planes and stuff. Where I got some photos for you guys. 2 more months till grad school apps. Yeah. Yeah, here, let me see. I got videos somewhere. Where was it? Where are the videos? Yeah, here we go. This is it. All right, cool. Here we go. Yeah, so this is it. Look at all these people. I think they had like 200 people show up for this. But it's at this airport in Compton, and yeah, they had the kids go up on the planes and things. Super dope. They get like. There were some kids that were like scared to fly. Where was it? Where were the kids that were? So one of the coaches was like, "Here, I'll do push-ups so you guys aren't scared." I thought that was really fun, cute. And then they had all these flight simulators so they could go like, I don't know, test out flying and stuff. And they had a lot of cool. They had like Boeing, United. It's a very cool organization, I'll say. I wish I had it when I was a kid. I wish I could like learn how to fly. That'd be dope.
That's dope.
But I'm partnering with them to maybe revamp some of their curriculum and put it into like a more fun format. Like what I do with the shorts on TikTok. They have like a bunch of lessons and things, and I'm gonna try to like make it more Gen Z, Gen Alpha friendly, I guess. Yeah. Where's your wings? Can't fly, unfortunately. All right, let's see what Haunted got. Haunted, let me help you out. All right, so again, if you want any help with your homework and you want to earn some credit and have me buy you V-Bucks and all the sorts of fun stuff, yeah, good. Geez, how do I earn coins? Yeah, good question. So there's a website there, actualofficehours.com. If you go to that website and you like type in whatever you want your username to be, something that I can recognize you by, and just drag in a screenshot of what your question is and hit upload, and then we'll do it here live on the stream. So it should be something that like is tricky in your homework, like you don't get. This is basically like free tutoring that can help you out with anything. We say like math or science. Try to pick something math or sciences. And once you do that, make sure you join our Discord, because then once you're in our Discord, that's where like I give you credit for things. And then once you get enough credit, I buy you gift cards and all sorts of other fun stuff. So let's see, in the queue so far, we got Haunted. Let's see what Haunted's got for us. Oh man, the existence of square roots. Okay, is this gonna be some analysis question? The website's right there, actualofficehours.com, Greg. It's I can't post links in TikTok chat because they're mean, but I can like leave the link as a picture. This is real analysis. Y'all ask me real analysis, dude. Yeah, see, unfortunately, I never took real analysis. Zach did, though. So, yeah. Zach, I know you took real analysis. You want to help me out with this one? It's never too late to start. Yeah, Zach and I were talking about like a Skillshare exchange where I teach him E&M. I think I would either want to learn from him either real analysis or discrete. I want to say real analysis comes up more. And you ran a whole course. Correct me if I'm wrong. I think you did. Also, let me shout out to Eric. Yeah. I know you guys did like a whole course. You did. Yeah, okay. I just need to like lock in and actually watch them sometime. Okay. Anyways, I'll try to answer this. I will leverage the help from my wonderful community here as well, because that's the beauty of the internet. We have people from all over the place, all sorts of backgrounds, all sorts of knowledge backgrounds and stuff, and like they can help me out with this. Least upper bound axiom: if a non-empty set of real numbers has an upper bound, then it has a least upper bound. Sorry, what's a least upper bound? That seems like an oxymoron to me.
Huh?
How can something be like the least most? You know? It's like the driest water or something. What? It's the smallest upper bound for a set? Isn't there only one upper bound for a set? An upper bound smaller than all the other upper bounds? All right. Well, let me try to. And this sounds fucking goofy, but okay. All right. So yeah, here's what I think I see what you're saying. So for instance, if I had a set of all the numbers that like sine of whatever like covers, right? There are a couple upper bounds that exist, right? The upper bound could be 10, right? There's no way this thing will go past 10. But also like 9, 8, these are all like ceilings. But the least upper bound, I guess, is 1. Because that's like the least upper bound to me sounds like the maximum value of the function. Just fancy math words. Oh, you want to come in a voice call? Yeah, please do if you do. Yeah, if you want to, Zach, yeah, come on in. If you want to help explain this one to me. I think you have access to our Discord, right? You should. I think I have you as a mod too. Okay, so I at least understand what least upper bound means. Okay, it says, if A is greater than 0... Yes, Ben, I see it. Or I see Greg's and I see Ben's. I see both yours. Nice. Okay, cool. All good. All right, I think I understand it. All right, here we go. Okay. Let S be the set of... Okay, so for the flight school kids, don't worry about this. I know this looks like super scary and stuff. Do not worry. This is like a college level question. We help all sorts of math and science questions. Sometimes we get like college level kids. Sometimes we get middle school. So this is an example of a college level question. So don't get too scared if you don't understand this, because I don't even understand this yet. But hang around and watch it, and you may start to like pick some stuff up. It's pretty cool. All right, I know this is a fancy math language for x is a variable, and we say that it could be a number that are all real numbers, and real numbers are just numbers that are not imaginary, I guess, right? Irrational numbers are still real, I think, right? So just like regular ass numbers, that's what this means. And we say that this number is greater than or equal to 0, and that the square root of it is, the square of it is less than some other number a. So for instance, if x was equal to 2, then a would be equal to 5. Or a could be 5, I guess, right? X is a real number. It is greater than or equal to 0. And the square of it, 2 squared, which is 4, is less than 5. Okay. Show that s does not equal this weird-ass looking 0. I'm going to guess this means it's not the null set. Is that what we mean by that? It's empty set, right? Okay, so like, yeah, empty set is like trivial. Okay, cool. So it's not the empty set, and S is bounded above so that S... this word, I don't like this word. It's like sup. This is called the supremum. I know this is called the supremum, which correct me if I'm wrong. I think the supremum is just the maximum. Oh, the supremum is the lower upper bound? Okay, yeah, so it's the maximum value. Okay, this is the... Okay, so this is the lower upper bound. Math people and their words, dog. You would have thought math wanted to stick to numbers, but then they just keep using words and stuff. This is where math starts getting scary. Okay, prove that s squared does not equal a leads to a contradiction. If s squared is less than a, then some number slightly larger than s is still in s. Or if s squared is greater than a, then s is not the least upper bound. You can lower it. I like how they at least put like some like nice English here. Okay, it's not quite the maximum value. It may not exist in the set itself. Like the negative numbers don't have a max, but they have a lower upper bound of 0. Sure. Okay, cool. Prove that s squared does not equal a. Leads to a contradiction. Okay. Jade, I'm going to say even my Diffie Q went well, plus my first goal for the maths football team at my university. Nice. Oh, you guys like play sports as a part of your classes and stuff? Like as a math team for sports? Okay. Hint, if 0 is less than u less than v, show that u squared is less than v squared by using v squared minus u squared is equal to v minus u times v plus u. Okay. How long do you spend for mission? I might honestly skip on this one, just because I don't really know how to do this one.
Surprise, motherfucker.
I usually spend like maybe 5-10 minutes on a question. I'm trying to understand this one, but this one's a little tricky. I don't know how to do yours, Ben. Are you sure? Well, let me see what yours is. Calculate the tributary for a yellow beam. Oh yeah, I don't know what this is. This is engineering, dude. What is this? Tributary? What's tributary area? Here. Everyone in my class is so confused. I think Zach's gonna come back when he's done with the kids. So let's come back to this once Zach comes back. And Zach knows. Zach knows real analysis and can help me out with this, because I'm trying to understand what this means. Like, if s squared is less than a, then some number slightly larger than s is still in s, and s is a series where x is greater than is equal to 0 and x squared is less than a, and a is a number. I don't know what is it. Can x be equal to 0 then? 0 is less than or equal is greater than or equal to 0, and 0 squared. Well, 0 squared is not less than 0. So, oh, by showing either. Oh, we could show either case. Greg, flight school is the only decent problem in the queue. Yeah, maybe we'll just skip ahead to Greg's question real quick. Let me see real quick here. If s squared is less than a, so let's say s, and s is the supremum. See, this is what I don't exist. This is what I don't understand. This exists, but then this is less than a? A is greater than or equal to 0? Oh, okay, and a is greater than to 0. Okay. Then there exists a unique r such that r squared is equal to a. S is a... Yeah, but then what's little s? I think S is like a unit that's in this set big S, right? Zero is an S, so S is not empty. Okay, here. Let me help out Greg real quick, because Greg is new. And Greg's from flight school. Let's not like scare Greg off with all the stuff. And then I'll come back to the other questions. Okay, here, let's try to do this. All right, Greg. Here, Greg. This is how this Discord works, or how this stream works, when I'm not getting like absolutely like messed around with real analysis. All right. This is cool. Wait, is this how you guys are learning to subtract mixed numbers? This is fascinating. Greg, please switch cases with me. Yeah, Greg has a happy life because Greg isn't doing real analysis.
Disqualified.
All right, let's see. Let's look at this. I'm actually really curious about this. Okay, Greg. So, they're teaching you how to subtract two mixed numbers, mixed fractions. It's funny, these don't really show up a lot. When you get to higher level maths, Greg, like, you don't really see this stuff, right? We almost never write, like, 5 1/4. We would almost always write that as, like, 21/4. Do you know how to go from, like, this to this, Greg? Or 5.25, that's another way. Yeah, great, right, yeah. Yeah, you do this times this plus this, right? Yeah, so this would be 5 times 4 plus 1, so that would be 20 plus 1, which would equal 21, yeah. Or 6 in engineering.
Disqualified, motherfucker.
Yes, I guess it would be. Yeah, you could also write this as 5.25. And then some Ben's being funny, saying that in engineering, they always just like estimate numbers to be whatever. So they would say like, okay, this is basically 5. 6 is obscene, dude. What? You can't call that 6. Brits call 21/4 a vulgar fraction. We say improper. That seems backwards. I feel like the Brits would say, it's improper. Yes, Greg locked in from a young age, potentially great future mathematician. He is, yeah. Okay. So, yeah, a lot of times, let's say, for instance, I wanted to do this. If your teacher gave you this 5 1/4 minus 2 3/4, the way you want to do this, I'll show you the way they want you to do it, and then I'm gonna show you the way that like I think you should do it. You should always convert these to what are called improper fractions. So this would become 21/4, and then this would become 11/4, right? 4 times 2 is 8 plus 3. And then as long as your fractions have the same denominator, the same number on the bottom, you can then just subtract the tops. So this is 21 minus 11, which would be then 10, sorry. And then this stays the same. You don't subtract this. You leave that the same. And so that would be 10/4. And then you could reduce this, or make it simpler. Simplify, sorry, by calling this 5/2, right? Because you could just divide this by 2, divide this by 2. This is technically correct. In the world of math and things, this is a correct answer. I assume because you're dealing with mixed fractions, your teacher would then want you to call this 2 1/5. Or, sorry, 2 1/2. Or, yeah, 2 1/2, sorry. Not 2 1/5, 2 1/2. But that's one way to do it. Whenever you're doing more advanced math, Greg, you're really just going to be dealing with improper fractions. We almost never deal with mixed ones. But, let's see. You could do them with mixed fractions still. The way to do it, the way they're doing it, is they say, okay, cool, 5 1/4 subtracted from 2 3/4. They're splitting up the whole number part and the fraction part. So, for instance, the first thing they're doing is the 5 minus the 2, and that gives you 3. And then they're doing this minus this. They're doing 1/4 minus 3/4. But then there's an issue with this. Right? This would give you a negative number. This would give you negative 2/4, which you don't want.
No.
Okay. So, when that happens, instead of doing the 5 minus 2 here, you want to borrow from this. So we're gonna. I know 5 is the same thing as 4 plus 1, so I'm gonna turn the 5 into a 4, and then I'm gonna add 1 to this whole thing. But 1 added to 1/4, 1 is the same thing as 4/4. So that's going to turn this into 5 quarters minus 3 quarters. Okay. So now this gets you 2 quarters. This gets you 2. And then if you simplify this, you get 2 and 1/2. Which is the same answer we got here, right? I think this is infinitely more confusing to do. I don't know why. I've never seen math taught like this. But it's okay. It is borrowing. It's like borrowing in just subtraction. Yeah. Okay. So, yes, that's one way to do it. So here, let's look at the example. This is another example they give us here, right? They give us this one minus. We'll do this one, and then I'll show you how to do the other one as well. I should go beef with his teacher. Yeah, to me this reads like some teacher took a Common Core class, and this is how they teach subtracting fractions. Which I don't know. It's just weird. Okay. So separate this into 2 things. So you have the 4 minus 1 part, and then you have the 1/8 minus 5/8. Okay. Now there's a problem here, because this would give you a negative number, right? 1/8 minus 5/8, that would give you negative 4/8, and you don't really want that, right? We don't want negative numbers. So when that happens, what you want to do is you want to borrow from here, from this top number. And so what I'm going to do is I'm going to borrow this and call this 3. I'm not going to borrow 1 from it, basically. And then I'm going to add another 8/8 to this one. So now this becomes 9/8 minus 5/8, which is equal to 4/8. And if we do this one, we get 3 minus 1, which gets you 2. So your final answer is 2 and 4/8, which you can then simplify this even further, because 4/8 simplifies to 1/2. And there you go. That would be the same. That would get you 1/2. Do you see how that works, Greg? Also, always let me know if anything does make sense. Like, if any of these parts were, like, confusing, and you're like, wait, hold up. You can tell me. That's the whole point of this whole stream. Is because I know in class, your teacher will, like, put shit up on the board, and you're like, that doesn't make any sense. Like, what? And then maybe you don't want to raise your hand, or your teacher doesn't want you to raise your hand. I know some teachers that say, like, no questions during class. I'm like, excuse me? What? How do you not have questions during class? Yeah. Gold, what do you think the best majors are for university college? Define the word best. What are you trying to do? You trying to make money, or trying to do what? Okay, all good. Good job, Greg. I'm glad you did this question. I will post this in our Discord, so make sure, Greg, so that you get credit for the question. Make sure you join our Discord here. Do you have Discord, Greg? I hope you do, because that's how we give out the prizes and everything. Just click join our Discord, and then just send me a DM what your username is, and then I'll make sure you get the point for it. You don't? Okay. Well, see if you can get Discord. Discord's great. Maybe there's, like, age limits on your Discord. I forget. I think you can be, like, 12 and still be on Discord. Okay. Anyways, no worries. All right, cool. Thanks for coming by, Greg.
Good job.
Enjoy. All right. Let's mark that one as done. That was kind of a fun one. That made me kind of I love the point of view on how math is being taught these days. That's a very suspicious way to teach it, I would say. Right? That doesn't make any sense to me. All right, that was Greg's. So let's post that. Oh, man. Greg. Okay, and then we'll delete 3. If you'd like, there is this in the worksheet that I forgot to send. Okay, I'll take a look at it. Maybe it'll help us out. Let me save this real fast for what we did with him. Greg. Okay, cool. Let's see. Let me do gladiators. I think I can maybe do this, or maybe I don't want to do this.
Oh shit, not good.
And then here, and let me add this piece of information to your question. Haunted. What's up, Obi? Put that into a calculator. There should be a way to like not have to use a calculator. Yeah, man, look at all this, dude. Like, what are all these rules? Why does math have so many words? This is way too many words for math. I had a lecturer last year who would insult students for asking questions if they were deemed stupid. That's the worst, dude.
Oh no.
That's someone who's stuck in their ways and just an old person. Shout out to Obi, by the way. Another awesome streamer. Where's my shout out? There we go. Okay. So we got that. I'm gonna work on it. So if I get progress, tell you. Cool. All right. Let's see what Gladiators was, which was this. There is no such thing as a stupid question. First day of classes in college, can I go to the bathroom? Okay, that is a stupid question. I agree. Well, I don't know. Maybe people don't understand that. I don't know. You're an adult in college, and like you. Some people, when I was teaching at UCLA, would say, "Would you get upset if kids were on their phones like during your class?" And I would say, "No. Like I'm not their parents. Like you're an adult. Like if you don't want to learn in the class, I don't have to force you to learn. Like that's on you, dog." It is my responsibility to make the class a little bit more interesting than what's on your phone, so that you don't want to be on your phone during my class. But yeah, the kids are paying for it. Well, it's rarely the kid that's paying for it. It's their parents. But yeah, I think that's probably one of the things is, at least in today's society, maybe the kids are a little too attached to their support system, to their parents. Yeah, so they don't have the autonomy to say, "Oh, I can just go to the bathroom." He was my personal tutor, yo. I ended up asking for a change half a year, and he stormed off a tutorial, even slammed the door on the way out. I don't know. It sounds like a dude has issues. All right, let's talk about Gladiator here. Solve for A given this. Given what? What is given what? What? Dude, what? Given this does what? Gladiator, I need some context on this question, dude. I don't know what the TH means. Yeah, it's not equal to anything. Yeah, what?
You're not that guy, pal. Trust me. You're not that guy.
Is it like equal to 0? That shit isn't even an equation. Yeah, it's an expression. Thursday means do Thursday. This is using Pascal's triangle. We learned it in stuff, I think. Okay. I'm still confused. Do you want me to like condense it or something? Heard he was let off a year before his loads reported him, but I guess he got his job back. Yeah, it's hard to fire people these days. In academia, at least. Oh, it's a series. Oh. No. I think it is a series. Okay, I think I get it. I think... Yeah. You think it's x plus cy to the end? Taylor series polynomial convert to Calc 2? I see. Is it the binomial theorem thing, right? I don't think it's x plus cy. X plus 3 over x to the 6th? Anyways, I'm off to the gym. Thanks, dude. Yeah, come on, Mike. Have a good time at the gym. Is this the binomial theorem? Yeah, what's going on here? x squared plus 3 over x squared. Oh no, JC. JC, what's happening? Yeah, can I see the full sheet for context, please? Thank you. Y'all are quick on this. I think I do understand. Okay, let me see if yeah, binomial coefficient. Okay. So let's see. It's this, right? N choose K. I think we need this. And then... yeah, how does it work again? This is it. This is what I want. Yeah. You sent the full sheet for context. Cool. Thanks. JC, you're going to lose more years than Jeff does.
Surprise, motherfucker.
Sorry, where'd you send it, Ben? Gladiator, where'd you send it? Oh, there it is. Okay. Factor and expand using Pascal's triangle. So I wonder if yeah, I don't think they're going to be using like choose and stuff in this. What's up, 1K? Yeah, so for instance, Gladiator, have you seen it written? Wait, no, I fucked this up, sorry. Have you seen anything written in this form before? Like, does this make any sense to you? If it doesn't, then we can just go find Pascal's triangle. It is Calc 2 technically, but I don't think Gladiator is in Calc 2. I think Gladiator is in pre-Calc. Yeah, okay, so, yeah. So we can't use this. This is the formal way to do it, but we're not going to use this because you're in pre-calculus. Never once saw that notation until Calc 2. Yeah. This is calculus for grade 12. Yeah, okay. This is not calculus. I mean, it kind of is calculus, series and stuff. Canadian calculus, maple syrup calculus.
Good job.
All right, let's go see Pascal's triangle. That is this one, right? Yeah. So when they say like use Pascal's triangle, do you literally just get Pascal's triangle? I mean, you can always rederive it, I know, but it would just be a pain in the ass. Yeah, so this is Pascal's triangle. So, yeah, just a little, like, some little fun intuition how this works, right? Every number here is the sum of the two numbers above it, right? So 1 and 2 become 3, right? And then, like, 3 and 3 become 6. And then, like, 1 and 3 become 4. And the reason why these are cool is these also work as the coefficients for, let's say, this is a plus b to the 0. Let's say this is like 0, which would just equal to 1. Do you see how that's just a 1? This, if it, sorry, it's a plus b to the n is how this works. This is what my channel's named after. Oh, yeah. This is a pachinko game, right? This is a pachinko. Yeah. Yeah, for, here, pachinko game. Jeff's like, I'm done, dude. Right? It's these types of things where they have all like the rain bet, that stuff you see on Instagram all the time, like rain bet. That's what this stuff basically is. Yeah. You would like drop a ball through one of these, and it's like, what's the probability that it like lands here and lands here? Anyways, yeah. So all the different levels of these are what are called the like the exponent thing on this binomial. So this would be a plus b to the 1, which notice would just be here, let me like just draw them out. This is a plus b squared. This is a plus b to the 3rd. And then this is a plus b to the 4th. You're getting the rules for the derivative. That's interesting that this is what they kind of, I don't know, the path you're taking is very curious here. Okay. Because this is 1 and 1, right? You see how that's 1a plus 1b? Then this is 1, 1, 2. All right, let's use different colors. Sorry. Let's use red. Okay. And the reason for that is the coefficient would be 1, 1, 2. And then it's going to be the highest power here would be a squared for a. The highest power for b would be b squared. That's on the end there. And then this is like the mix of the two, and this would be ab. What happens is this is like a squared b to the 0. And this is technically b squared a to the 0. And then as you go 1 over here to the right, this goes up a power, this goes down a power. And that's why this is a to the 1, b to the 1. And then this one is just b squared a to the 0. But a to the 0 is just 1, right? And b to the 0 is just 1. So that's why a plus b squared is equal to 1 plus, is equal to a squared plus 2ab plus b squared. And so you can skip down a couple. And the same thing works here. For instance, a plus b to the 4th. So you could write out what all the coefficients will be. All right, so let's write the coefficients. So 1, 4, 6, 4, 1. So that's 1, 4, 6, 4, 1. Those come from Pascal's triangle. And then the terms, so the leftmost here is always this. Sorry, this should be to the 4th on the outside. It's this to the highest power, so this is a to the 4th. The rightmost is this to the highest power, b to the 4th. And then you fill out in between. So then this would be a to the 3rd, b to the 1st. This would be a squared, b squared. Then this would be a to the 1st, b to the 3rd. And then this is b to the 4th. So that's why you get a to the 4th plus 4a third b plus 6a squared b squared plus 4. What's up, Amir? 4a b to the 3rd plus b to the 4th. Okay. Does that make sense, Gladiator, where this comes from? Like, and I'll show you. This is how you can go from here to here. We're then going to work backwards. And I'll show you kind of a cool method for figuring out the backwards part. Yeah, that part's good. Okay, cool. All right, so let's get to here. All right. So first thing you want to see, right, is what is the highest power on the left, and then what's the highest power on the right. And highest isn't technically the most positive, the most negative. I'm talking about like just which one has the biggest fucking number on it. All right. So here, I noticed the biggest is like to the 6th, right? And here the biggest is to the negative 6th. Right? So, and then let's see. And then how many terms are there? That's also important, right? So there's 1, 2, 3, 4, 5, 6, 7. 7 terms. 1, 2, 3, 4, 5, 6, 7. Okay. So we need one with 7 terms. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I think it's going to be this one, right? Yeah, of course, JJ. Yeah, you can get help for sure. Go to that website, actualofficehours.com. Submit your screenshot. I'll help you out. I'm taking requests for the next, almost 2 hours for sure. So I think we're going to use this one. And so this was to the 0th, to the 1st, to the 2nd, to the 3rd, right? To the 4th, to the 5th. So then this one is to the 6th. To the 6th power, all right? So I know right off the bat, I need something plus something all to the 6th. Okay? And then the first thing, right, will just be whatever this is to the 6th. That is just x. There's nothing else in front, right? So I think this just has to be I think this is just x here for this one. And then maybe let's look at the last one, right? So the last one's going to be something to the 6th. And then it needs to go to the negative 6th. So that's going to be 1 over x to the 1 over x, right? Right? Because that's how I get 1 over x to the 1 over x to the 6th is the same thing as x to the negative 6. So then I have to wonder, okay, but how do I get something to the 6th equal to 729? Rating a small channel. What's up? What's up, Shaq? So, I need my calculator then, I think, at this point, right? I'm figuring this out alongside with you. I don't think I've ever really done this before. Party of 2. What's up? Thanks for the raid, Shaq. Shaq's a fun mod in our server, and he's really good at Fortnite. Let me give you a shout out, Shaq. Go follow him. It's cool to we like supporting our student streamers. Okay, so the 6th root of 729. How long do you stream for, Shaq? That's the same thing as 729 to the 1/6. 3 hours. Oh, dope, dude. Okay, cool. All right, so that's 3, right? Okay. So right off the bat, I know this is going to have to be 3 over x. I do need to try. Thank you, Shaq. Okay. Let's see if that makes sense, right? I think it will. Is this what you said, by the way, JC? Is this what JC had? Let me see. JC said it was x squared plus 9 over x squared to the 3rd? But wait, wouldn't there only be 3 terms then? You need 6 different terms, right? All right, so... Oh, it is my form? Okay, cool. Okay. All right. So, to sum things up, Gladiator, what you want to do first, just like, here's like the mechanical procedure, see how many terms there are, okay? If they for sure say this is like a Pascal triangle thing. In this case, there were 6. Wait. 1, 2, 3, 4, 5, 6, 7. Sorry. There's 7 terms. So minus 1 gets you to the, we're going to say to the 6th power. Okay? And then all you have to do is look at the leftmost thing and the rightmost thing. This needs to be a to the 6th, basically, right? So a to the 6th is the first term. And then b to the 6th is the last term. Assuming everything else is okay, right? So now we have it in this form. We can expand it out, right? So it's going to be the first thing to the 6th. So that's x to the 6th plus 6. And then that's going to be x to the 5th. And then this is going to be 3 over x to the 1st. Which is just cool, right? Notice here, right? X to the 5th over x. That'll get you x to the 4th. And then 3 times 6 will get you 18. That's why you get 18x to the 4th. Okay, so that one's okay. It's checking out. All right, so then we have 15. And then this is x to the 4th. 3 over x squared. Plus 20. X to the 3rd. 3 over x cubed. Now, how far do they want me to go? They want me to go to the 1, 2, 3, 4. They want the 5th term. Ew. Okay, fine. So we've done 1, 2, 3, 4. We got to do one more. And that's going to be past the 20. That's going to be 15. You could have gone from the other side as well, but I just wanted to show it to you here. So this is going to be 15x squared, and then this is going to be 3 minus x squared. So notice what's happening. The power of the first thing is going down by 1. the power of the second thing is going up by 1. Sorry, this should have been to the 4th, not squared. Sorry, there we go. Does that make sense, Gladiator? Let me know. Okay, so then you just solve? Yeah. Well, you gotta do a little math here, right? So you get x squared over x. Or it was interesting, not x squared over x, sorry. So it's 15 times 3 to the 4th, and then it's x squared over x to the 4th. Which 3 to the 4th is gonna give you... is that 81? I think it's 81 times 15. And then this is x to the minus 2. So then 15 times 81 is just 1215. So you get 1215 x to the minus 2. Right? And that looks about right? Yeah, okay, cool. 'Cause it seems to be like kind of in between. Yeah. Nice. Okay, so then here, let me do this one real quick, just showing you like kind of the similar strat, or have you kind of like go along with it more. We'll do it over here. Yeah, you see that now? Okay. So then what would this one be? Let's try to do this, Gladiator. So first thing I want you to tell me is like, what's the power going to be? Because we know it's going to be like a plus b to the something. What's the power going to be? Four, right? Okay, let's look. So you have 1, 2, 3, 4. You have 5 terms, minus 1, 4th power. Good. The power of love. Sup, nerds? What's up, Psychode? Okay. So then, all you got to do, right? Look at this. And you know that this thing, a to the 4th, has to equal 81x to the 4th, right? What does that mean a is equal to? You know it's at least equal to x, right? Because the x to the 4th will get my x to the 4th here, but then what is this going to be? $3x, good. Very good. Right, this is 3x. And then if we look at this, right? That's the last term, which is right here. So that's b to the 4th needs to equal 16y to the 4th. What does b equal to? B is equal to y. Good. Exactly. Oh, I don't know why that went where. Okay, cool. Okay, cool. So now, you know, half the battle's done. We found out what the polynomial was. So this is going to be 3x plus 2y, all to the 4th. I think Jeff already said this. And what term are they looking for? They're looking for the second to last term. So here's a cool thing. We don't need to go like all the way here from left to right. We can now go from right to left. Because I know this is going to be like blah, 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 blah. And then the last term is going to be 16 y to the 4th, right? But then the one before it is going to be 4, right? Times something. It's like... This is going to be 4 a to the 1st, b to the 3rd, right? Because this one right here was just b to the 4th. All right, and then we know what a is. A was 3x, so I'm going to say 4 times 3x times 2y to the third. And that's going to get me 12 times 8. And then we're going to have x, y to the third. So then that's going to be 96. X, y to the third. Which, was that one of the answers they wanted? Yeah, cool. Right, so in that case, A is equal to 96. Yeah, so instead of going all the way from the left all the way to the right, I just started at the right and just went 1 over. So A equals 96. Cool.
Good job, good job.
Well done! Well done!
I hope that makes more sense to you, Gladiator. That was fun. I enjoyed that one, actually. Yeah, you're very welcome, dude. Hell yeah. All right, cool. Yeah, that was a fun question. All right, so we're gonna take that. We're gonna put it into our Discord. That was. I'm gonna mark 2 is done. Nello says, what's kind of funny is that I'm from Alberta. When I apply to Ontario universities, I get an extra 4% to my admission average because of the rigor of Alberta curriculum. But what I do in school is no harder than what Gladiator is doing in Ontario. Really? Is that kind of like their, I don't know, like their affirmative action, per se? You just get a 4% bump just because you live somewhere? That's funny. Okay, cool. So here's your question, Gladiator. It's in the Discord. So what we'll do is we'll drag the screenshot in. So there you go. So that'll have the solution for you. Give you a coin for it. And then also, new feature, if you ever want to see where in the VOD this got recorded, this link up here always has the YouTube recording with the timestamp of when we did this. So you can always go back and watch it pretty easily there. Did you know that you can get the Fibonacci sequence from the Pascal triangle? I know they're related somehow, I guess. For Waterloo, they get an adjustment factor based on the school. Okay. We talked about the Waterloo effect yesterday, right? We talked about like what happens if you go to Waterloo. Yeah, so grade inflation is a very big problem, even in the United States here. And this is what I wrote on LinkedIn, actually, 2 days ago. There's an article about college students at UCSD who have perfect 4.0 GPAs from high school, but, like, can't do middle school math. Right? And it's just like, what? And it's because, again, high schools kind of just pad their grades as much as they can to make sure the parents aren't mad. Like, most parents don't have the time to really investigate what their kids are learning in school, and they only look at the grade. So as long as the kid has all A's, they're happy, right? The second the kid doesn't have all A's, then they start getting mad. So I think some teachers defensively just give good grades to kids because they just don't want to deal with the parents. Well, I mean, you would hope that middle school... No, see, Ben, the difference is that middle school math is used in high school math, which is used in college math. Like, arguably, like, learning how to add and subtract fractions is not, like, one-time knowledge you learn in 5th grade. So, yeah, the big issue is that a lot of colleges in the U.S. got rid of the SAT as a requirement, which I was in favor of at first. I was like, yeah, dude, fuck the SAT. Like, I hate the SAT. It's a terrible exam. It doesn't really test how smart you are, per se, and I don't know, it's just like a little... But the issue with getting rid of the SAT is then what do kids have to then demonstrate that they, you know, have aptitude in math, or, like, you know, they learn shit. You would hope, their GPA, or like how they did in high school, but you can't trust that anymore because the schools just inflate it. So getting rid of the SAT was actually a bad thing, because now you have some students who, again, don't even know how to add fractions, who get into colleges because you never had the SAT to, like, give them that, like, body check of, like, no, bro, like, we need to make sure you learn more math before you try to go to college. Like, you're not there yet. It's okay. But, yeah. What if they're a bad test taker? I know. I don't know. You need something. There's always gonna be what ifs. There's always gonna be exceptions. But for the resounding majority of students, you know, it does work to test whether you know, like, basic math. Yeah, you need standardized tests. I hate them. Don't get me wrong. I think they're all money grabs and they're terrible. But standardized tests is how we at least put some level of standardization of skills that before you get into college you can do. Yeah, I also, this is the whole dilemma where I think 40% of Stanford says they're disabled. Like, what? You guys seen this before? Stanford. Yeah, nearly 40% of students at Stanford claim they're disabled. Yes. Because, universities offer perks to those that say they have ADHD, night terrors, even gluten intolerance, and you'd be stupid not to game the system. I agree. It's pretty fucked. Oh, thank you, Zach. Yeah, Zach, I was waiting for your opinion on this. Is that actually true? I mean, I will say in my class, yeah, for sure. When I taught at UCLA, I had a huge majority, not huge, well, what I think is huge, but I would say maybe 20%, 30% of the kids had some sort of accommodation thing. Some of them were more legit than others, but the whole issue is that you can't, like, question it. I can't be like, how disabled are you? Like, you can't say that. It's a problem. So what I would tell the students, because, the extra time students, right, they would go take it at a separate place that was, like, quiet, and they got twice the time to take it, and okay, cool. I would tell the students that, well, if you want to ask me questions about the exam during the exam, you have to take it during the exam time, like, in the classroom, because it's not fair to everybody else that I would have to then allocate more of my teaching resources to, like, have you take it somewhere else at another time. Yeah. Kempy, do you have a question? Thank you, Kempy. Yeah, never take it. Yeah. Also, I think those that are using it to game the system are only, like, screwing themselves over, because you're living with a crutch, and I think you said it right, Ben. The second you get to the workforce, they don't care if you have asthma.
You done messed up.
They don't care if you have ADHD. Like, the projects do. Like, you don't get extended time on a deadline. When you're applying for grants through the NSF, they don't give you double time because you have night terrors. They don't care. It's like, I saw there was a what was it? Something about feelings, but you still have to milk the cows. One second, let me see. Situations come and go. Cows need to be milked and fed. It's a boomer quote for sure. I love it. Where's it? Exactly. Yeah. Wait. Yeah, it says rain. It's something about, like, rain, hail or shine, the cows still need to be fed, and whatever, still need to be milked. I think what they're trying to say there is that, like, your personal situations are your own, and, like, for sure, like, you deal with mental health, you deal with, like, whatever. There's tons of shit going on that individually, like, sucks, but the world still goes on, and somebody needs to do things. So the world doesn't care if you're having a bad time, because things need to be done. Yeah, night terrors. I have day terrors, exactly. Yeah. All right, sorry. I would love to discuss this more. I have math terrors. And standardized tests. I'm curious, Zach, what your opinion would be, the alternative for the SAT. I think they 100% need to just bring it back. All right, let's see. Kempe. Find the indefinite integral. Remember to use approximate values. Cool. Well, this is easy. Kempe, what? You know how to do this. What are my thoughts on Common Core? I don't know enough about Common Core, but if Common Core is anything like what we saw here,
Bruh.
I think it's kind of whack. I think they're just coming up with goofy ways to teach math. Okay, here we go. 2x over x minus 2 squared. Oh, actually, I don't think this is necessarily just simple. Oh, okay. Ooh, spicy. It's a spicy question. Because Kempe, like my default is to try to call this like U, but then du doesn't exist on top, so that doesn't work. My next thought is partial fractions. Can we do partial fractions? You think it's partial fractions? Can you do partial fractions if you got like variables on both sides? Maybe. Because what? This is 2x over x minus 2, x minus 2. I don't know if you can do partial fractions this way. Usually this would need to be like a number. Right? And in this case, if this was a number, right, then this would be a over x minus 2. Plus, I think, like, bx plus c? Or no, plus b over x minus 2 squared. Yeah, I think that's what it is. But this is 2x. So I don't know how that works. Check how many points the question is worth. 6, 7. Okay. Zach says, I think just have a unique test per university. Ooh, I don't know about that. That's a lot of tests then, because kids apply to like 10 colleges. I don't want kids taking 10 different tests. No one is trying to standardize how tests are given across institutions, so if we're going to accept that institutions are largely acting independently, at some level, just let them have their own battery of tests. Common Core is 18 minus 9 is 10 plus 8 plus negative 10 plus 1. Dude, that's too much, dude. Stop.
Oh shit, not good.
Yeah. Open response test. Yeah. The reason why they do multiple choice, true, false, again, it's just numbers. We just don't, they don't have graders. They don't have enough graders to grade all these things. I like those things, Zach, but I think they're not realistic from like a cost point of view. It's easy to score. You think it's easy to score? I don't know. It's very easy for it to just run through a Scantron. Maybe with AI, we could get AI to score things. I know you love that. If there is the SAT, what do you do for kids that went to academic bad schools in bad areas? You send them to community colleges in better areas, I think. That's what happens a lot at least in the UC system. If you don't make it into like one of the UC schools, and I've had tons of students, even people in my Discord have done this. You go to community college, you demonstrate that you can get good grades with college level curriculum, and then it's basically an instant admit into UC. Yeah, I agree that open response is subjective. Like math is math. I think maybe what Zach's talking about is that you could have partial credit on math, maybe? Is that what we're saying? If you know IU do science and math, but it's an AP government, a good idea to take. Yeah, it's a good credit. Yeah, It'll get you out of some GEs in college. Yeah. Okay. Let's... Oh, also, yeah, this... I feel like this integral is not defined at x equals 2, right? Don't we have to take a limit here? Like, this is an indefinite integral, so it's not defined at 2. JC says u sub. JC, what's the u sub you see, dude? What are you going to say? Are you going to say that expanded and reverse change? U equals x minus 2? Okay, wait. If u equals x minus 2, then du just equals dx. Okay. Alright, that's cute. Okay. See, when I do u sub, I always want the derivative to show up somewhere else, but it doesn't. Uh-huh. Thank you, Parath. Yeah, you guys are right. X equals u plus 2. Okay. So, x equals u plus 2. 2x equals 2u plus 4. Now my integral is 2u plus 4. Oh, I see what this is. Because now this is u squared. And then this is just du. Oh, beautiful. Okay, cool. Because then you can split this into two integrals. So this is 2u over u squared. I always forget about this trick. 4 over u squared. Winner, winner, winner. Chicken dinner.
Good job.
Don't forget the du's. This is calc 1, yep. Okay, so that this is 2 over u du. So that's the ln. I want to say this is absolute value of u times 2, right? Plus, and then this is going to be, so minus 4 over u, right? When I do this one. This is the same thing as integral of 4u to the minus 2. Raise it, divide by it, and then u is equal to x minus 2. Don't say plus c yet. I'm not done yet. I'm not done. You can chastise me once I'm done. X minus 2 minus 4 over x minus 2, right? I think that's it. Minus 5 points from Golden Door House. Alright, this is plus C. Okay, and then... Yeah, there you go. Cool, great. Awesome. Yeah, nice. I think it's it. It's a constant. Might as well just call it C. Is there a song I'm missing here? I'm missing a song. Nice. Kempy, does that make sense to you? Yeah? Big dog? I don't think I watched it. You guys want to link it to me? I'll go watch it. We're having a pretty slow day on office hours today, which I'm cool with. I have to go back to the gym and do cardio. Yes. All right, good job. All right, we're going to go watch a video in a second here. Good job, Kemps. Can you write down instead of plus C, XCR like in stats? What's XCR? What? All right, add one. Add one to the Kempmeister. Charlie XCX. She has a new movie out, right? Charlie? I remember watching Charlie XCX back in like 2012 when she was like EDM. All right, let's see. Calculus Rhapsody. Is this X defined? Is F continuous? How do you find out? You can use the limit process. Approach from both sides. The left and the right. What, dude, this was made 16 years ago? Jesus. Okay, this is brilliant. It's 6 minutes long. All right, I'll watch the whole thing at the gym. Where's the part where it says plus C? Add a constant labeled C. Might as well just call it C. I'm just a constant. Nobody loves me. We're gonna go find that part. Oh wait, there's. Oh dude, man. There's a lot of it.
I'm just a constant.
Constant.
Nobody loves me. He's just a constant. Might as well just call it C. Never forget to add a constant C.
Okay. All right, I'm never gonna forget that then. Yes, he's just a constant. Might as well just call it C. That's brilliant. All right. Let's see. Ben, what was this? I don't know if I can even do this. The reduction factor of two beams, dude. This is such like civil engineering stuff. Calculate the tributary area. This is steel design. Fascinating. So wait, someone's building like what do we call this? Oh, Hamilton, William Rowan Hamilton. Is that where the Hamiltonian comes from? It's a bay frame. Ooh, bay frame. It's a bay frame. What's up, Haunted? Oh, maybe Zach's here. Maybe we can help out with the real analysis question. Just because I don't know if I can actually do this. What is a bay frame, by the way? Is it for like holding things? Like what are you putting in the bays? A 3D structure. Okay, cool. Bay frames are the well-built ones. Best bay, my bay. Best bay, my bay frame. Yeah, I don't know. This is cool. This is what you do in engineering. So if you guys want to get into engineering, just heads up. This is the type of stuff you'll have to be doing. Seems kind of silly to me. Oh, you did? Nice. Do the third question. Who's the third question? Let's see. Or do the third question on here. Calculate the LL reduction factor for the two beams. You see, I don't know what an LL reduction factor is. Let's see if we can help Haunted out. Just because I know a little bit more about numbers, at least. Noah Bagley says it's the distance halfway between each top and bottom part of the beam. Each top and bottom part. Two beams above, yellow beam and red beam. Live load. Y'all are speaking a different language. Dude, existence of square roots. Proof by fucking obviousness. It's a square root. Okay, let's go see. Let's go see what this one was. Okay, I see. Let me try to do this one. That's tributary area. All right. Existence of square roots. Oh, man. I can't swear in my Christian stream.
Huh?
This is far from a Christian stream. Nothing wrong with Christianity, but I like to say we're kid friendly. We're not family friendly. Okay. Maybe let's like walk through like what ChatGPT says and try to understand it. Because that's what I would do. If I had absolutely no clue how to do this, I would have AI teach me real analysis. I really would have Zach come teach me real analysis. But I know it's also getting late. S is bounded above because x squared is less than a. Okay. ChatGPT and proofs aren't well mixed together. Okay. All right, so let's talk about these things. It's bounded from above, and I agree with that because the set contains all elements x, and x squared is less than a. Well, wait, does that tell me x is bounded though? It tells me x squared is bounded. How does it tell me that the set is bounded? No, it's like, what happened? The question changed. Yeah, we're going to the first question that got asked today. Just because, yeah, I don't know engineering stuff. Okay. It sounds like something someone would set as an axiom, so I'll go with yes, yeah. Prove that s squared does not equal a. So okay, and s is the supremum, which is the lower upper bound, and I think from what we said is that, like, s does not have to be in the set. Is that what we said? S doesn't have to be in the set, but it can be if it's the supremum. And then prove that s squared is equal to a, where s is the supremum. No, that's okay. Yeah. So I'm just going through the statement. Show, I assume s is not the empty set, and s is bounded from above. That, I guess, we're coming from this. And then it says little s is the supremum of s exists. And then my question was, does the supremum, is the supremum in the set or it's outside the set? Capital S. It doesn't have to be. Okay, but it can be. Okay. Prove that s squared equals a leads to a contradiction by showing either if s squared is less than a. So if the supremum squared is less than a, then some number slightly larger than the supremum is still in S. Wait. But we said S was the lower upper bound. So if it's the lowest upper bound, right? Nothing can be greater than it, right? For instance, 0, 1 has a supremum of 1, which is not in the set. I see. Okay, so that's the contradiction. I get it. I think I get it. If s squared is less than a, then some number slightly larger than s is still in capital S, right? And that's a contradiction. Because little s is supposed to be either the biggest value of capital set S, or right outside on the boundary of it. Okay. And then it says, consider this. If u is less than v and both of these things are greater than 0, show that u squared is less than v squared by using v squared minus u squared is equal to v minus u over v minus u times v plus u. Well, this is the difference of squares identity. How does this work? I agree this is probably necessary, because here we're dealing with x squared is less than a, but here we're dealing with, like, s squared is less than a, but also you're proving that u is less than v minus u. Can't you observe that t squared equals 4, therefore square roots exist? I wish. Okay. All right. Actually, I like what Zach's saying here. Sorry, let me move this down. I don't really know about this stuff. I don't really want to deal with this. But let's deal with this. I kind of like this. 0 is less than u is less than v. So if this is smaller than this, right, then v minus u has to be greater than 0, right? I agree with that, because this is bigger than this. And they're both positive, so you can't have any funny business happening with negatives. Okay, cool. Then if you multiply both sides by v plus u, okay, so v plus u this is also greater than 0, right? Because v plus u is a positive number, right? We said these are both positive, right? We can say, like, because positive. Great. Now I'm lost. Bring the engineering back. Noah says bring it back. Okay. All right. Oh, very cool. Then, okay. Then, by sum of squares, right? V squared minus u squared is greater than 0. So v squared is greater than u squared, or u squared, right, is less than v squared. Nice. Sorry, difference of squares. Yeah, you're right. Not sum of squares, sorry. There is no real sum of squares. By difference of squares. Okay. Yes. All right, that's cool. That's cool. So we showed that if something is less than something else, then the square of it is less than the square of the other thing, which I think was maybe useful for this, maybe. Because we're doing, I don't know, I see like square shit going on. Oh, wait a minute. Yes, Zach, that one does work. Wait, I think I see something here. Wait a minute. Okay. Wait. If x squared is less than a, right? I want to say there's some square root thing happening here, right? Can I say this? Then x is less than the square root of a? Because of what we proved here? No? You're showing that you're showing this exists? Well, I wanted to kind of to say it. Oh, I see. We can't use any properties of square roots because we haven't shown that square roots exist. Dude, this is why real analysis like blows my mind. I'm like, what? We're not allowed to assume basic things about numbers anymore. Like everything's a lie. Yes, we don't know rigorously that square roots even exist. Yeah. So I can't even include them in my proof yet. It's so funny. Okay. If you did, you'd have circular reasoning. Yeah, sure. Have you proven that the supremum for this set exists? Well, it's maybe we haven't. we have shown, like I said, it's not the empty set, right? Because you could have x being equal to 0, 0 is greater than or equal to 0, and then 0 squared is certainly less than some number a, right? And a is some number greater than 0. And then, if the supremum exists, you have to show that it's bounded, right? Let's think. Okay. One thing we did show, though, right, is that, oh, man, this is the circular reasoning I'm trying to think. Okay. From this, 0 is the floor of x, and the ceiling, well, the ceiling is for x squared. Maybe RJ Peach, this thing, right? Yeah, right. What did we prove? We proved earlier that if yes, thank you, Zach. Come save me. What's up, Zach?
What's up?
What's up? Oh man, real analysis. This stuff always like blows my mind.
Closing the door. What's going on? What's good?
So I'm chat is talking about how I think I need to prove this stuff first before I can even move on to like the contradiction things. Is that like true?
So you need to establish that this exists, and I think we did that. Like you said that 0 is in the set, so that's non-empty, right? You got that part, and then you have the bounded above. You got that with the green box, right? So we're good there.
Well, so that should be that
so
x squared is bounded. Does that necessarily show me that x is bounded if x squared is bounded, or is that what came from this?
It's an element of the set. You're creating a set of that definition, right?
Okay.
And so as long as you know that A is the largest thing that could possibly even be in the set, but it's not. A isn't in there because it's, less than or equal to. But you know that the thing is bounded above, and 0 is good enough for, you just need one thing in there.
Okay.
I guess I don't understand your question.
No, I get it. I wonder if there's like some particularness to this, like x squared is less than a. Oh, I see. Because if I plug 0 in here, 0 squared is just 0, and then that tells me 0 is less than a, but 0 is something in the set, right? Is that what we're saying?
That's right.
Got it. Okay.
Both statements are true.
Got you. Okay. And then if it's bounded from above, does that mean the supremum has to exist?
That is literally the definition. As long as you have it's the axiom you take. It's called the least upper bound property, or sometimes it's also given the name axiom of completeness. So that's what you're seeing there.
I think that's what was given here.
Completeness axiom 1. Every non-empty subset S in R that is bounded above has the least upper bound. You literally check those two conditions.
Good. Okay.
Right?
Yes.
So, and it doesn't need that statement doesn't need proof because we're taking it as axiom.
Axiom is like, it's assumed, it's law. Like, I don't need to question it.
It's assumed, yeah. Like, you don't have to do any proof at all of that. That's just like you treat it like a definition in some ways.
Got you. Okay. So then the next step is to prove that s squared equaling to a leads to a contradiction where s squared is the supremum, right?
Right. So you want to say s squared is not equal to a, which means that you would need to show that it's either less than or greater than, right? If you show one of those two, then right, like those are the only other options. You have three choices. You have
Right.
greater than, less than, or equal to. And
I
it's
get it,
not
I get it.
equal to.
So I have like there's three things in the universe that can happen. I could either have s squared is equal to a, or s squared is less than a, or s squared is greater than a, and both of these is s squared does not equal a. So we're saying either of these
That's right.
would imply this,
So I have.
which would then lead to a contradiction.
So the easier case here is s squared bigger than a, in my opinion. I think this is easier because if I know that s squared is bigger than a, then s squared is now an upper bound. That's not the least upper bound.
Oh,
Because we said
okay.
a was the upper bound, right? Right? So that like a is an upper bound and s squared is the least upper bound, which or
wait,
s is the
S is the-
go back
S
to
is-
go back to the way they said it.
Sorry.
S is the least upper bound.
S is the
Sorry.
least upper bound, right? Yeah.
Yeah. So did I say that backwards? Hold on, because sometimes these get messed up in my head too.
No, for sure. You're okay.
Okay, let's go back to look at their hints. The way they express it is better than I'm going to express it, I think.
Oh,
I
okay.
like
See,
the
for this
written
one.
versions of this. So
Okay, here we
let's go
go.
to the first one. Yeah, so s squared less than a, then some number slightly larger than s is still an s.
Mm-hmm.
Okay? Are you is that convincing to you?
Let me think. So if s squared is less than a, then some number slightly larger than s is still in s. Oh, okay. But we said that earlier, right? S. If s is less than something, then if s is less than a, then s squared is also less than a, I guess. Oh fuck. Or is less than a squared? All right, one sec. Okay. If s squared is less than a, then some number slightly larger than s. This would mean that s is no longer the supremum. I agree with that, right? This would mean that
That's right.
that s
Right,
is
that
no
would
longer
be
the
the conclusion.
supremum.
But you've got to, right? So what you might want to do here, some number slightly larger than s. We should probably write down some formalism here.
Okay, let's
Because
write.
when
yeah.
you say something slightly larger than s, how can we notate that? Let's
I
like you
like
might want to say
epsilon, right?
something like epsilon's great. So a number slightly larger than s would be like s plus epsilon.
Okay, s. Okay, would be s plus epsilon. I agree.
And then
Okay.
we square that.
Okay.
Right.
So then let's
now
do
that
that.
is bigger than s.
It is, right? Because that's s squared plus
We can
epsilon
even
squared
multiply that
plus
if you like.
2s epsilon. Yeah. Which is greater than s. Yeah.
And that which is greater than s squared even.
Greater than s squared. Yes.
Right?
Okay.
Right? But we said that how do we say this? There's a
Is this kind of like true?
that s squared is less than hold on. We gotta actually make sure that's true. I think that yes, we can say that because we can say that yes. We can't
'cause we
square root anything.
But
Don't
we
do
proved
that.
we're not gonna square root, but we proved it from this, right? We said that if
Don't go to the unique.
don't do the uniqueness thing, no.
We're making assumptions. Yeah, no uniqueness thing. Don't
Okay, I can
focus
use
on
this.
that. We want to focus
All right, I'm not
mostly
gonna
on.
use I'm not gonna use that. Okay. Fine.
This is harder than it looks, chat. Trying to talk this through. So
No, please.
if
You're
you
talking
wanna
off a
come-
building.
Okay, so what we're gonna say is s plus epsilon squared. You wrote it correctly that the s squared plus epsilon squared plus 2s epsilon is bigger than epsilon or bigger than s squared.
Good.
And we need to let me go back up to what you said. What those two hints were. I want to be able to see those because I like the way I like the way they phrase these hints.
Let me put them right
Having
here.
it side by side.
Let me put them right there. One second.
I get lost sometimes
You're
on these
totally
proofs.
cool. Totally cool. Does that help?
Right. So what we're gonna do. Okay. So what we're gonna do is take. How do I want to say this? You want some number slightly larger than S. So we want to show that this thing is an S, right? How do we show that?
How do we show that S plus epsilon is an S? Is that what we're showing, or S plus epsilon squared?
Mm-hmm. Well, how do we know? Like, what's the condition for something to be an S?
Okay, the condition for something to be an S, let me pull that down, is this whole thing. Here, let me get rid of this. Let me get rid of all the stuff I was drawing. This is wrong. Okay.
Yep.
Okay, there we go. Okay. This was the condition. Okay. So to be in S, you have to have the condition, first of all, that you're greater than or equal to 0, which I agree, right? Because epsilon is greater than 0, right?
Mm-hmm.
And then we need the condition that it's bounded by that whatever it is squared is bounded by something bigger than it. That's A.
Mm-hmm.
Okay.
Yep.
So I don't know that this is necessarily.
So certainly, this
isn't bounded by anything though yet, right? I know S is bounded by something.
We know S squared is bounded by something, and if S squared is bounded by something, go ahead.
Okay, I see what you're saying. You're saying S squared is bounded by A, right? Is it bounded by A? Okay. Then S plus epsilon squared must also be bounded by something, A? Or maybe A plus
But
epsilon?
why is that?
See, that I don't necessarily... If it's in the set, it has to be true. But I don't know if that is true. Because in my mind, S plus epsilon squared could be bigger than A. If S squared is less than A, right? S squared is less than A, sure.
Yep.
But then this is bigger than this, so I don't know if this is bigger than just this or if it's also bigger than this.
Right. So what you want to say is, you know that there's some. I'm trying to think of how to say this. You want to say, you know that there's some epsilon bigger than 0, right?
Okay. Yeah. Epsilon
right. So for some epsilon bigger than 0.
I agree with that.
Like you said, you've got this thing chosen. So that means that there's going to be, how do I want to say this? You say, it's been so long since I've done these, done this proof. So
it's my first time.
If you want to,
no, you're good.
Help. Yeah, I was gonna say, I wasn't expecting to get on here today, but I think it's a good thing we did.
I appreciate you are.
Right.
Take as much time as you want. I don't care.
Let's see here. How do we want to say this? We say that S. I mean, you have the question about series, which I know I could answer right now. Like, I feel a little more confident on that one. But like,
what series? The mathematician guy. Oh, he's okay.
He's
got to give me a question first.
About integration test and all that.
Yeah, no, that's fine. That's
okay.
Fine. Don't worry about it. That's fine.
So like, okay. So we say epsilon is that. Who that? Why am I blanking here? Because you want to basically show that whole expression is also less than A, right? And you do that because you know.
Yeah, I want to show.
What
right?
am I missing?
Okay. I want to show that S plus epsilon squared is also less than A, because then I would say that it's in the set, right?
Mm-hmm. That's what we want in the end.
But S squared is always greater than S, which would be a contradiction because S is supposed to be the supremum.
Right.
Right. I think I see the logic of how that's going around. So I just need to show this.
Right. Less than or equal to, somebody's saying in chat.
This is Haunted's question. This is his question, Haunted. Yeah. So.
Right. Wouldn't it be less than or equal to? I believe that's correct, but I'm trying to think of, like, there's something technical I'm missing here, and So try this. We know that epsilon is bigger than 0,
Yes.
which means that S plus epsilon is bigger than S, right?
S plus epsilon is greater than S.
Let's say it this way. Yeah. So
I
right?
agree.
Which means that S is bigger than S minus epsilon.
S is bigger than S minus epsilon. Yeah.
Right? And S minus epsilon is not the upper bound. We know S is, but S minus epsilon is not.
Yes, this is the supremum.
That's
this
right.
This is the supremum.
So there's going to exist some element that if I square these, because what we really want is that there's something in between S and L. I'm doing this sort of backwards, but I'm trying to think of how to say, because there's a way to say this so that, gosh. Yeah, we're trying to, so JCYW, Joseph, we're trying to prove the fact that I can't choose a lower, what is it? I don't know why this is so hard, but like that we can find an element that is bigger than S squared, but that's less than A. That there's some element that exists between the supremum squared and A, if I assume that S squared is less than A. And I feel like I'm missing like one detail here. Where's Narosky?
Where's Narosky?
Better at these questions.
Where's Narosky?
I'm better.
Where?
Like these were always like the. That works too, but you
Okay.
can't say square root because. Oh my
That's okay,
gosh.
Jashek. Do you want
I'm
to
gonna do a little cross-referencing here.
do you want to see a little hint?
Let me see.
You want a hint? This is what chat says a hint is. I don't know. Maybe this will.
Oh, is chat helping?
No, I mean this ChatGPT.
Oh, GPT. Oh,
But-
boo.
Boo, I know.
Boo.
But does this illuminate anything? Does this click? I'm gonna convert you, Zach.
That's it. You're
Does that
not
help
gonna
you at all?
convert me. I'll never join you.
Disqualified.
This is Luke Skywalker talking to Darth Vader here.
Yes,
right? Like,
join me, and
I'll
we shall
never
take over
join
the
you.
galaxy.
sorry.
I agree.
I'm done.
JC's like, what the fuck is this? I agree. I'm just like, yo, where did this come from? Where did epsilon suddenly become the minimum of
I'm
one
not
in
sure
this boogeyman?
I'm not sure I'm supportive of that.
Yeah.
Because
okay.
you're
Okay.
yeah.
No, it's okay. Just no. I just didn't know if it clicked anything. Sometimes like
No, it does not. No, it doesn't.
I see the first line of something from chat, and instantly I'm like, oh, okay, I know exactly where this goes now.
This is what I want. Here, let's
Okay.
go with this one.
Let's go with this one.
I think it's better if we go with an example that
Okay, here we go. Stack.
this is what I'm trying to do, and I think it does it better.
All right, proving the
job.
existence of the square root of 2.
This is the same idea.
I love this. It's
I
like-
know that's stupid, but just
Oh.
hear me out, okay?
Okay, all right. All right.
And
So
go down to the first response. This is gonna do it. So let's just go through this. All right.
let
So
S
you
be
let
the
this
set.
S be the set. Go ahead
Uh-huh.
and you go.
Oh, you good. Let S be the set. Y is greater than equal to 0. Y squared is less than 2. Thus, S is in the set of all non-negative numbers whose square is less than 2. Okay. Observe that S has an upper bound of 2, because if Y is greater than 2, then Y squared is greater than 4, which is greater than 2. Oh, okay.
There's an upper bound. It's right. We know there's something that exists that's above everything. So
Yes. Oh, because 2 squared is 4, and we already said that
That's
Y
right.
squared was less than 2. Okay. So it does have an upper
That's
bound
right.
of at least 2.
Also, S is non-empty, and we constructed that element. They chose 1, but we're choosing 0. No big deal. We can figure out. We have something that exists in
Sure.
the set, right? So whatever we choose, that's irrelevant. They chose 1 just because they have a specific A, but they're doing this for a specific A. We're doing this for just modifying.
We're just showing that
argument
square
where we
roots
see 2.
exist, not just the square root
That's right.
2. Yeah. All right, good night, JC.
Good night, Joseph.
JC's like, peace, dude. Thank you, JC.
4 a.m. I'm proud of you for being here.
Yeah, shout out to
at 4
JC.
a.m.
Yell at JC more so he starts streaming again. That's our main thing.
Yeah, we need more
chemistry questions for JC.
For that. Yeah.
Okay. All right. We argue by contradiction.
OChem. So
Yeah, OChem for all of it. It says we show that x squared is less than 2 and x squared is greater than 2 lead to contradictions. Okay, because I guess
this is what we were talking about.
It can't be both, right?
Go ahead. Yep.
Okay.
So we do what we just said. X plus epsilon squared.
Mm-hmm.
We expand that out.
Mm-hmm.
And then they're doing something here where they say epsilon is very small, so something less than 1. This is where I think GPT is trying to make an argument for 1 being an upper bound. This is what I was trying to get at, and I couldn't think of. Maybe that is what we needed to do here. So what you do is you say, well, I know epsilon has to be less than 1 and positive, so I can bound above this expression that we have, this x plus w epsilon squared. I have a way to bound that above, and all those inequalities are just saying we can bound that above by something.
So wait, how is 2 epsilon x plus epsilon? Yeah, how is 2 epsilon x plus epsilon squared less than 5 epsilon? Where did that come from?
Okay, well let's go one step at a time here. So look at the inequality. Would you agree that if epsilon is small, that when I square a number between 0 and 1, if I square it, it's actually smaller than it was before. Than
epsilon. I agree.
Right?
Okay.
Right.
I agree with that.
Good. And then
x is bounded by 2.
Well, we already...
X is bounded by 2.
Mm-hmm.
So that's why it's 2 times 2.
So there you got it.
Okay, cute.
So that's I can pick those. I could have picked something else, but it works. Okay, so now we know that x is less than or equal to 2, and epsilon squared is less than epsilon. Since x squared is less than 2, we can see that we can choose that epsilon that we want, such that x squared plus 5 epsilon is less than 2. We can choose that epsilon. We get a choice, remember? Mm-hmm. So we get to choose any epsilon we want bigger than 0, and as long as I can make the choice, which I can, for any x, I'm good to go.
Thus, x plus epsilon squared is
for
less
any
than 2.
epsilon bigger than 0.
For any
so as
epsilon,
long as there's one that exists, we're good to go.
Okay. By construction method, this means that x plus s. But this contradicts that x is the upper bound. Okay. Oh, wow.
There you go. This is what I was trying to do, and I couldn't think of how to upper bound it, and that's what I needed to do. So
we had to come up with something cute.
Glad we had the written out response here.
Yeah, we had to come up with this x squared plus 5, which is cute. X squared plus 5 is less.
Now you do it the other way. Oh, sorry. I'll let you process.
Wait, 1 second. Yeah, sorry. Let me process this for a second. Sorry. Wait. Since x squared is less than 2. Okay. Wait, one second. Did we assume that? Yes. Okay. We said this. X squared was less than 2. Okay. So x squared plus 5 epsilon. How is that also less than 2? Wait. Sorry. X plus epsilon squared, which is certainly bigger than x, is equal to this, which is less than x squared plus 5 epsilon. Okay. And then epsilon squared.
So here's what happens.
Mm-hmm.
You know that x squared is less than 2.
Yes.
There's going to be some number that I can choose. It's somewhere in between 0 and 1, so that this x squared plus 5 epsilon is less than 2. That I can pick that.
Oh, how? How can you pick an epsilon? How will you be able to do that? Sorry.
Because I'm trying to think of how to say that. We say that because how do we say that? We say I'm trying to think of how we do that. Go ahead.
Let me paste this in so I can kind of expand it out a little bit so I can think.
Yeah, 5
epsilon.
Haunted is saying 5.
Oh.
There's going to be some number out there that we can add. We know
Yes.
x squared is less than 2, right? So like when we say something is less than 2, it means there's this little space between x squared and 2 that's bigger than 0, right? There's some space between
We're
those.
like saying x squared is better.
I don't know how big that
is less
space
than
is.
this. Is less than that, right? That's kind of what we're saying.
Yeah, we're saying that there's something in the middle, and I'm going to find out what it is. And because
Yes.
there's a less than sign, this actually leads to something pretty deep. Because what I'm saying about the real numbers is that there's a space
Yes.
that's non-zero, right?
Yes.
And because there's a space that's non-zero, I'm going to magnify that space so that it, in some ways make it. I'm going to say, well, I can make that as. I can pick since there's some
zoom in
distance,
as much as I need to.
I can zoom in as much as I need to. Exactly. I'm trying to think of how to say that out loud for a novice, right? Like you don't think about it like this, but that's what less than means, and leads to what's called an open set. Like the
I feel like
concept
this is
of
like
open
Zeno's
set is
paradox.
these open spaces. In some ways, yeah, it is. Yeah, it's that I can always make more space.
I can always find more space.
Yes. So this epsilon and Haunted is saying exactly right, that I can make that epsilon pretty small to accommodate the space that there is between 2 and x squared. And there's going to be something. It may be really teeny, but I can find it.
Okay, all right. So we know x squared is less than x plus epsilon squared. I agree with that. And we showed that this thing is less than x squared plus 5 epsilon, right? That's what happened when I expanded this out.
Which we know.
Yes. Which we know what? Sorry.
Less than or equal to. You can put an equal to there too.
Sure.
It couldn't
Okay, that's
be
fine.
equal, but
Okay.
okay. But we know that is bounded above by 2.
How do we know this is bounded above by 2?
Because remember, the difference between 2 minus x squared, there's some space there. So whatever that space is, let's divide it by 5 and call that epsilon.
Okay, one sec. The 2 minus x squared thing. That
Right?
That jimmied my Russells or Russled my Jimmy.
So-
Where was that? That
Okay, so write that down. Let's write that down because this is a non-trivial fact and at the very core of analysis.
Okay, all right.
Okay?
Let's
Like,
let's
this
get
is
to
like one of those things you got to know.
Okay.
So think of it this way.
So
Think of it this way.
Yeah.
What is the next number? If I say here's the number 1, what's the next real number after 1?
2 or 1.001.
I can do better. Yeah, 1.001. But I can do better than that. gonna be a
1 plus
troll
epsilon. 1 plus epsilon.
Yeah, right? Right.
Okay.
I can make it as small as I wish.
Yes.
Anytime you give me any finite number, like 1.0001, I can always make something closer
Yes.
to
Sure.
1.
Sure. You go low, I can go
And
low.
so what I'm saying, exactly. So what I'm saying is I can find some epsilon between x squared and 2. If I take the difference between 2 and x squared, subtract them, right? And then divide that by 5, that's going to be my epsilon. I can find out what I need to make it, right? So I know that thing exists because we chose.
X is less than x plus epsilon. I agree with that, right? Is this? I'm trying to maybe kind of think about this. And so if x is less than 2, you're saying I can always find some epsilon that's in between it, like this. There's always there's
Yes.
something. There's
Yes.
something
That's what
non-zero
I'm saying.
that will
There's
force this to
something
be
there.
correct.
That's right, non-zero. It may be teeny, but it's there.
It exists.
That's
Oh, good job,
wild.
Edvin. Good job, Edvin. I'm glad you passed your exam. Sorry, I'm failing my exam in real analysis. But no, I'm getting it. I think I'm getting it. I think I'm getting it, Zach. Thanks for being patient.
I want to. No. I want to stress something here that this is a non-trivial fact,
Yeah.
and like what you're engaging with is exactly what a novice in the subject should be doing. This is what gets at, for example, what an open set is.
Yeah.
And there's like a whole bunch of, when you talk about topology, this is all the stuff in topology that people hate. It's like, oh man, there's that space there. We never make it that clear. Most professors will just say, oh, this thing exists, and they'll move on. But engaging with this question of like, what you're doing right now is what a novice should be doing. So I want to say very clearly that you're getting it. You should be struggling with this because this is a non-intuitive fact, and we don't make it clear very often.
And it's also helping Haunted. Haunted says that they're understanding it a lot more. I think Haunted understanding a lot more is like name of the game. If Haunted gets it more with my struggling, I'm 100% happy with this.
Right.
Fuck yeah.
Yeah, right. Exactly. So,
okay.
100%. So let's keep going.
Where was the divide by 5 thing? Sorry.
We established that the space exists.
Where was it divide by 5
I'm dividing
thing?
by 5 just because there's a multiple. I'm doing that because just because there's the multiple of 5 there. I'm trying to get rid of the fact that we're multiplying by 5. So if I choose an epsilon, I'm just saying, like, there's going to be a scale factor of 5 on that epsilon, but really, because I can make it as small as I want, it's fine.
Doesn't matter. Yeah, okay. Got you. Okay. So I can say that. Yeah. I can say this.
Remember, I can make that space as big or as small as I want.
Now, this was x, not x squared, right? But is there differences with that? Sorry. No, but we said x squared was less than 2. Okay, so I can just fucking call this x squared if I wanted to. Okay, that's fine. Okay, I understand this.
You can. Well, the way I just want to make it clear for the benefit of those watching this and like making sense of the madness that's going on screen.
Yeah.
What you wrote on the first line and what you wrote on the second line are 2 different things.
Correct.
The second one is more for you, Gold, but making sure you understand. But I want to make sure that the first statement is really what we care about.
Yeah, this is for me.
Yeah.
Okay, but this is the thing we really care about. Yeah.
That's right.
For proof. Okay, for the proof, x squared is less than x plus epsilon squared, which is less than x squared plus 5 epsilon, which is less than 2. Okay. And then
so as long as we've established that this epsilon thing that makes some sense now.
Okay.
So thus we have now established that x plus epsilon squared is an element of the set.
Oh, okay. Is in S. Yes. Because it satisfies that it's less than something, it's not equal to 0. Oh, I see. I think I'm starting to see it now. Muscle flex for channel points 1. What's up, Justin? I see what you're saying. Basically, is it saying that like we can never find? Oh, I see. It's basically saying that unless s squared is equal to the supremum, or sorry, if oh man, dude, I'm on the cusp of this.
So what we're saying is that the inequality sign inherently leaves space between x squared and a.
Correct.
And
yes,
that
there's
I can
always
magnify
space.
that space however I like. There's always space here.
Okay, great. Okay, there's always space.
I can fill that space. I can always use that space to my advantage to create something closer to a than x squared was.
Correct.
That's like the moral of the story.
Moral story. I get it. X squared less than a doesn't really tell me much because I can always find something that's slightly bigger than it but smaller than a.
And we constructed that thing through a series of bounds. And those bounds that we made, the epsilon bounds, like x squared plus 5 epsilon, is just a way of saying, I know that there's something there that is bounded above by 2 and so on and so forth.
Okay.
So anyway, that's...
Okay, how does this show that a square root exists, though?
Okay, Well, we're not there yet.
Okay.
Because all we've shown is that s squared is less than a. Is not right. So it's
Or
not
less-
less than a. It can't be.
Okay. We've showed that s
Because
squared
we reached
is.
a contradiction, right? Like
Oh, we showed that s squared is not less than a.
that there's something. Yeah.
Because there's always something in
what did we-
between.
what did it say up there? It said
I guess not equal to. Is this like the not less than a? Because of this,
Yeah.
right?
yeah. If s squared is less than a, then we can find something else, and then s squared no longer becomes the least upper bound. That's the problem.
Was s squared
Because
always?
s was the least upper bound,
thought-
and we found something.
I thought s was the least upper bound. This is where I'm
S-
starting.
Correct, but s is a positive number, so if I square it,
Yes.
right, and then I take something slightly bigger than it and square it,
Yeah.
that says that the new thing that's so what we've shown is that there's an element still in s, but since we said that s was our upper bound, we no longer have that as the least upper bound. We found something that's bigger. That's the upper bound of s.
Oh, I see. I see. I see.
Look
I
at
see.
the next statement on. Look at the next statement on that proof, because it's in there. It says in the next
This one?
sentence what we can conclude. Go back to the thing from Stack
Oh,
Overflow.
from
'Cause, like,
Stack
the-
Overflow.
the author.
Yeah.
Yeah.
Okay.
So if you look at this,
What part?
it says by construction of s. So going to that next line. By construction of s, this means that x plus epsilon is in s. But this contradicts the fact that x is an upper bound of s.
By construction of s, this means that x plus epsilon is in s, but okay, because x was supposed to be the supremum. Okay.
That's right. And we found something bigger that was a supremum, so there's a problem here. We can't conclude that s squared is bigger than a, or is less than a.
Oh, I see. I see. Oh, I see. I see. Okay, I think I'm starting to see it. Yeah. Okay. Okay. Yes, because x plus x
This
plus
is
epsilon
one
is greater
reason
than
why.
x.
Mhm.
Go on. One reason why what?
This is one reason why people hate analysis so much. People hate this analysis stuff so much because it messes with you. Inequalities mess with you, and that's what's happening right now. This is one reason why in the school curriculum I honestly believe that they teach inequalities is to help you get ready for stuff like this. But frankly, no one really does, and we don't talk about it this way. Usually, inequalities are talked about as a you know. I don't know, means to some other end. But really, an analysis professor is expecting you to have this deep understanding of the inequality symbols, when in reality, many people don't. Like this is what you're doing right now is like relearning some inequality stuff that you're like, oh wow, I haven't, I never thought about it like that.
No, for sure. I feel like I've been like rebirthed
It's
into the world of math.
Yeah,
Okay. Being reborn.
it happens.
It happens.
Being reborn. Phoenix coming from the ashes, right?
Yes.
That's exactly what this is.
That's what's happening. Yeah, we're
Okay,
still in the
so
burning
with
stage.
All of that to say,
Yes.
all of that to say, x squared is less than 2 is an impossibility. So now what we've demonstrated is x squared less than 2, not possible. Like that, where x is the upper bound.
Got you. Yes.
Okay, supremum. Now let's look at the other case. We have one other thing we have to check: could it be that x squared is bigger than 2? And that's where we can go back to the.
Let's go back to here.
That we just saw it.
Sorry. Oh, was it in the
Right,
stack
and that
exchange
actually
thing?
is in this. It's stack over. Yes, it is.
Oh, okay.
right?
Okay. Sorry. Here it is. Okay. Yep. Okay. All right. Suppose that x squared is greater than 2.
You take the wheel.
Yeah, let me try. X squared is greater than 2. Let epsilon be less than 1 but greater than 0. X minus epsilon is that polynomial, which is bigger than minus 2 epsilon x. Yes, okay, because you got rid of the epsilon squared, which is bigger than. Oh man, but now, dude, the inequality's going the other direction, so now I'm getting. Oh fuck. Oh yes.
But
Okay.
think it
Okay.
through.
I get it
Think
because
through.
you're subtracting a bigger number, right? If x is equal
Yep.
to x can be at max 2. So whatever my number is has to be bigger than subtracting 4. Because I won't
right.
ever be able to
That's
subtract
right.
4 technically. Okay. Got it.
That's right. So, and this only works because epsilon's positive. So because, and specifically epsilon squared, but like we're okay. All right. So now here comes the finish. We got x squared bigger than 2. So we again can make some choices, right? We know that x squared minus 4 epsilon is bigger than 2. Why?
Oh, interesting. Okay, one sec. Because x squared is greater than x squared minus 4 epsilon, and x squared is greater than 2, and there must be some space.
So there's some space in between. Yep.
Yeah,
and that
let me put that
space
down here.
is.
Let me put it somewhere. Where do I want to put it? I want to put it here. Okay. Here, I need to like draw it out a little bit.
I mean, if you wanted to draw a number line, you can.
I like
you
the
can
number
draw a
line.
little,
I really like the
here's
number
x
line idea.
squared. Yeah, you do that.
Okay.
This might help a lot.
All right. This is 2, right? This is 2, and I know that
Yep.
x squared is greater than it, right? Somewhere over here. I know x minus epsilon squared is less than that, right? This is x minus epsilon squared.
Yep.
Okay.
It's somewhere in between.
And that thing's even bigger than x minus 4 epsilon. Or x squared minus 4 epsilon. Okay.
We're just making more room.
We're just making
That's
more
all.
space. So I can keep finding like an infinite number of epsilons that will make more space between x squared and 2. Right?
Yep.
And
Yep.
all of these things would
That's
still
exactly it.
all these things would still be in the set, right? I think.
Yep. Or
Okay.
they'd be bigger, right? And
Oh, we're on the other side of the two now.
essentially, so let's keep going. Right, we're on the other side. Yeah, you're doing the exact same argument, but you're doing it on the greater than side.
Oh, I see. Right, because our first argument was that x squared was... Sorry, we're trying to prove that just x squared is not equal to 2. So we showed that, okay, what happens if x squared is less than 2? Now we're showing what happens if x squared is greater than 2. Okay, and how this would lead to a contradiction.
Yep.
Okay. So, I see. Then this can't be the least upper bound because I can always find something that's less than it as an upper bound?
Yep.
Okay.
And so let's just read the rest, just for the sake of completeness here. Pun intended.
Okay.
Completeness.
Then x minus
Love
epsilon
that.
is an
Anyway.
upper bound for s, which contradicts the fact that x is... Oh, but this was supposed to be the least upper bound. Oh, okay.
Yep.
Okay. I think this always like kind of helps me, right? And then this x squared is less than x minus epsilon squared. I see.
Yep.
And I can always find more of these.
Yep. Which
Yeah.
we know is bigger than 2.
Oh man, that's such a clusterfuck. Okay. All right, great. Okay, cool. So, yes. So, okay. So, now what I'm saying is that x squared has to equal... Sorry, x squared has to equal a. But wait,
Yes.
doesn't that contradict the whole definition?
Squared. That's the... No.
Oh,
No,
s, but s
squared.
is
There's a
not in the
difference between
set.
x-
S is not in the set.
That's right. Right.
Okay. Okay. So s squared has to equal a.
All of... And all of what we just did was just playing with inequalities. Like,
Yeah. Okay.
really what it was recognizing what it means to be an inequality, which is a very deep thing. Like,
Bro,
this is so
like consciousness. It's the question of
non-intuitive to
consciousness.
people.
What is it like to be a box? What is it
Right.
like to be a bird? It's like, what is it like to be an inequality?
So, right. And the point of an inequality is there's some space between you and the thing you're less than or greater than. And I can always magnify that space any amount I like.
Oh man.
That sounds so weird when you say it out loud, but that's like the core idea. And frankly, what makes so much of analysis so hard is that people don't come in knowing what I just said. Like that is the thing that, like, the struggle you just went through, I think is what the struggle that everyone goes. I went through this struggle. Like,
This is not a
everybody
unique
goes through
experience.
this at some point. And like, it's completely no, this is not unique. What you're doing, like, the visuals you are drawing on the number line are absolutely essential, I feel.
Yeah.
And again, not something that most professors will just go run through this and
I think
say,
most professors
oh,
would
well,
just leave it
you
like
know,
this, and you're
This
just
is
like,
obviously
what's going
true, and but leave it like that. And then you feel the need to copy, right? Because you just like, oh well, that's the way it works.
Quick.
But yeah, like.
Wow. Okay. So wait. So if s squared, if s squared has to equal a, then is that what we proved? S squared has to equal a. Then that means that a square root has to exist. That's what we showed.
Because now I've got, we've shown that now.
Okay.
This element exists that s squared equals a, and so there's a number whose square is a, which means that I can find some number that is the square root, and we're done.
Okay, so s squared is equal to a. So can I say s is equal to square root of a now? Can I say this?
Now you can. Now you can. Well,
Okay.
So what you did is prove exist. That first half was about
I see.
existence, showing that
I see.
something exists. That second half you did showed that the thing was unique. That there
I see.
actually is one and only possible choice. The existence says that a choice is out there, but we don't know if there's only one.
Right. And we
Right.
showed it can't be less than a, it can't be
But-
greater than a, it has to be equal to a.
Right.
So
But are there more than one thing? And then that little inequality you did in the second half was about, okay, that little manipulation you did was to say, yeah, it has to be only one choice.
yeah.
So it must be now the square root of a. Yep.
Wow.
And that's what we define. Now, the whole meta here is that these are the games people play with formalism, right? This is one reason why formalism is so hard, is you have to think very abstractly about what an inequality means. And what, like, you're now trying to write that down in a very formal way instead of just drawing arrows on a number line, right? You actually have to articulate using formal symbols what it means.
We'll leave that as an exercise to the reader.
Well, and so for those of you watching this and wanting to know what real analysis is about, this is one of the early lessons in real analysis, which is, again, in my opinion, just this whole thing about inequalities. You're just learning inequalities better than you did before.
Wow.
Yeah.
Haunted, does that make a little bit more sense to you? Makes a lot more sense to me. Oh, Zach already posted the link there, yeah. I'm doing epsilon n proofs, so that gave me some background. Okay. I don't know what epsilon n proofs
Oh,
are.
epsilon n is another fun one. We did one of those, I think, during that marathon stream you did when I got in here, and I think we tried to help you through that. But I don't know. Maybe what we could do.
Oh, these.
You remember that? Yeah, those things. Yep. Yeah. Oh.
Oh man. Oh, this is like epsilon delta, but. Oh man.
Epsilon n is slightly better than epsilon delta. Epsilon delta is worse in my opinion.
Anything can be better than epsilon delta, dude. Epsilon delta is the literal lowest maximum global whatever thing, minimum of calculus and math, in my opinion. I hate epsilon delta.
But you learned a thing today.
Dude, I'm so thankful. Thank you so much, Zach. Thank you for like hopping in and donating your brain cells to help my struggling brain cells. Like it makes a lot more sense to me. I'm still very
For
shaky on it.
science, right? Like
For science. It's for science. But I and this is proof that you can teach an experimental physicist some sort of understanding of real analysis. Yes. Haunted says, thank y'all, it helped a lot with all caps. That means the number one.
I'm glad that helped.
Yeah. Glad Haunted. Yeah. Haunted, make sure you're following Zach, by the way, on his channels on Twitch. Here, I'll shout him out in our Twitch as well. But yeah, Zach is go, yeah. He says he's, yeah, totally. He's on the calendar too. So if you go to the website, go to the streaming schedule, Zach's streams are on here as well. And so he's streaming tomorrow doing DiffyQ stuff. So yeah, you can go click on his link there. I really appreciate Zach because you know so much more higher level math than I do, and also you know how to teach it. Like, you're very patient, which I think is such a rare thing of people that have high levels of math knowledge.
I try to think about what I would have been like in your shoes. Like, that's honestly what it is. It's like, I really am just trying to think about myself being in a class where to be completely blunt with you, when I was doing analysis the first time, I first engaged with it, I got a C- in the class. I did not do well. And I know how it feels to get run over, right? Like on these in these classes, it's so easy to do. And a lot of it boiled, you get steamrolled. Like I did, and I had a really good professor who cared about me, who knew my name, and like could actually knew a little thing about me. That was sort of nice, but I still struggled. Like, even if you have a good person who's trying to help you, it's just tough content. And honestly, there's a lot of things we can do better. And those who succeed at real analysis are often seen as a candidate for grad school. Like, that's what usually, if you want to go to grad school in math, this is one of those. This and abstract algebra are the two classes you have to be good at in order to succeed in grad school. And I'll be honest, this is not a it's not.
This is like the weed out class, like OChem for med school.
In some ways, yeah. For a math major, this one and abstract algebra are the two that people will usually judge you on.
Wow, that's so cool. Very dope. Okay, awesome. Well, thank you, Zach. I appreciate it.
For better or worse.
For better or worse, what? Sorry, what'd you say, Zach?
No, sorry. It's just they'll judge you for better or worse on this class. I don't know.
Yeah.
I don't know what else to say.
Is Haunted? Are you trying to be a grad math student? Is that your goal in life? You want to do grad math? I'm curious why Haunted is having to do such questions. Also, I will end the stream on this one. Habaka, if you're in here, I see you got chemistry. It's a shame JC left.
Surprise, motherfucker.
He would have been so happy to see chemistry. Haunted says, I'm like trying to do undergrad
in geometry though. I could.
This one you know how to do, right?
Go ahead.
I was gonna say that.
I do know how to do this one. I can do this.
He says he's doing research. I'm taking analysis next year. This is for my research program. Oh wow.
Oh wow. Yeah.
Props on you, man.
Hey, I can do this one.
Okay.
Gold. I actually know how to do that.
Or you know, I'm gonna give you the hard one.
5.
5?
Give me the hard one. Okay.
No, I'm gonna give you the hard one. I'm gonna give you 12.
Is 5 a hard one?
No, 12 is the hard one.
Is it 12? Okay.
Yeah, 12 is the hard one.
Okay. Let's see if we can do it. Is there some ion thing that I have to remember?
Nope. Nope. It's just bouncing.
So it's gonna be. Let's see. So we're gonna do. Oh gosh, we've got 2 hydrogens and 2 oxygens. Okay, that's true. This one is hard. So
I gave you the hard one.
we have to do. Yeah, you did give me the hard one. Which means we're gonna have a 2 on the HCl. I can already tell that because we've got the 2 CLs.
Good, I agree with that.
2 HCls, and then we're gonna have another 2 hydrogens, which means we're gonna need a 2 on the H2O.
Okay.
And that should do it.
Machka says all of them are 0.
All of my. Well, I mean. You're not wrong.
He's not
I
wrong.
think I did it. I think that's it.
Let's see. Let's see.
One,
One,
two, two,
one
one. I think
lead,
that-
one
that
lead.
checks out.
2 oxygens, 2 oxygens, 4 hydrogens, 2 and 2. You did.
Hey, we did it. All right.
There you go. Nice. There you go, Habaka. That's how you do it.
it.
Yeah. So there's a funny thing. The reason why I thought this one was hard is because you have H's mixed in here, and also in the OH. That's what makes it kind of tricky. One thing that sometimes helps students is whenever you see H2O, refer to that as just HOH. And this sometimes like helps out.
That's
so
an
now
interesting
you
way
can
to say it. Yeah.
you can see here I have 2 OHs. Oh, so I must have 2 OHs from here. And then that also leads to 2 hydrogens, which means I need 2 hydrogens here. Yeah.
I mean, I think I'd make JCYW angry on this if I say this would be hydrogen hydroxide.
Yeah, no, it's like, yeah.
Hydrogen hydroxide.
Hydrogen
for
hydroxide.
water.
Yeah. I mean, the funny thing is to say that it's dihydrogen monoxide, and they always make this joke. It's like, go to parents and be like, did you know that dihydrogen monoxide is responsible for, like, 99% of all, like, deaths in the ocean or whatever? We should ban dihydrogen monoxide. We should ban it.
That one, yeah. Don't do that.
Don't do it. Don't do it, guys.
That was good. Okay.
Edro says you're doing that. Yeah. What's up?
Go ahead. I'm gonna just mute myself and I'll let you do your thing because now I'll talk your ear off. You know that.
No, I love it. Yeah, we could have conversations for hours and days, and we should just do like a podcast sometimes, Zach, like similar to what you and Penn do, or like talk to Penn and just have me like come on the show one time. We could just like rant forever on things.
Yeah, that'd be fun.
Yeah.
I mean, I'll just come and help you like this. I can come help on occasion. I can't guarantee I'll be able to do it all the time, but
no, for sure.
Can do that more often.
Yeah, on the harder math stuff, you're an absolute gem for that stuff, 100%. Okay. Yeah, Edra, I was gonna say one quick thing on this question that comes up. So usually when you're balancing reactions, so for instance, if they're simple ones like this, we learn to just do this, which you just list out all the different elements you have. So in this case, I have C, I have F, and I have BR, and then you put on the other side, and you just need the numbers to equal each other. So I always like assume that there's just ones on everything to start off. So that would be 1 carbon, 1 carbon. I'd have, how many Fs? 4 Fs. This I would have 2 Fs. And then here I would have 2 bromines, and here I would have 4 bromines, right? So we're already good here. And then you got 92 in the quiz? Nice, dude. Good job, Edro. So in order to balance the Fs, right, this would then need to be a 2, which would make this 4, which is happy. And then in order to balance the BRs, you just make this a 2. And that makes it, yeah, this is a very simple example. Where things get more complicated and where I see students always messing up is, I think, stuff like this. Whenever, here, everything was pretty separate, right? Carbon was here, fluorine was here, bromine was here. Like, there was no mixing. But, yeah, and the tough one I gave Zach, for instance, was similar to this. Doing this, if you write it out this way, you can see, like, oh, I have carbons, I have hydrogens, and I have oxygens, right? Carbons, hydrogens, and oxygens. The problem here is that, especially in this case, oxygen is shared on 2 different things. This is a case where you don't want to use HOH as an approximation for H2O because there isn't any OHs over here. If you have OHs on the other side, you can kind of think of H2O as HOH. But in this case, there is no OH here, so there's no reason to think of this as HOH because you're not going to try and balance OHs. But students always mess up with, like, which one do you try to balance first? I always say balance the most complicated thing. So don't balance the oxygens first. Anytime something is by itself, you balance the thing last, right?
I am going to give one piece of advice here, though, that counters that.
Okay.
Only because you notice that on the left, there's an O2, which suggests that you need to have an even number of oxygens, unless you go some fractional number. But like, I wonder if it's, you know, that might actually be a good thing to keep in mind, that you want your oxygens to be even.
Correct. Yeah. And yeah, you're very right.
So-
Yeah. Because this is the only source of oxygens, and it has a 2 on it. So whatever you put here times 2 will always be another even number. And so these have to add up to an even number eventually. Metac. I've never heard of Metac before. What is Metac? Let's say Metac. Bouncing. Metac bouncing chemistry. Oh, metal, ionic, non-metal, hydrogen, oxygen. Oh, fascinating. Oh, they have a whole little acronym for it. I just say
mnemonic.
Yeah, mnemonic. Look at that. Metal, ionic, non-metal. I haven't seen that one before. Oxygen, yeah, usually gets bounced last. So yeah, in this case, the most complicated thing I think is like this. So I just want to bounce these, whatever's here first, which is bouncing carbon. So if this is 1, then this will probably be 1. Great. Okay, then look at hydrogens. I got 4 here, which means I need to put a 2 here to get 4 there. And then oxygens, well, now we have what Zach was looking for, right? We have an even number. I have 1 times 2, which is 2, and then 2 plus 2 is 4. So we got 4 oxygens here, and then that makes this one super easy to balance, because then this is just 2. Sorry, there you go. Yeah, and that's how you do it, and that's one. Yeah, these aren't too bad. The ones when you have like odd numbers and fractions, those are trickier. I don't think I see any of those here. But yeah, the fraction ones suck. I remember those. Maybe this would be it. I don't know. Oh, Skeleshit says, I finally got the square root of 2 proof. Thank you again. Nice. Wow, Zach, somebody else was trying to prove the square root of 2, apparently.
Well, look at that.
Look at that.
I'm glad it helps.
Yeah, I'm glad. Yeah.
It tells me that something worked. I mean, some I don't know what snapped for you. It would help me. So like,
yeah,
Haunted and Skella and all the others who are benefited from this. I'm curious what snapped for you. Like, what is it that did it? I don't know, like what if it was anything even that I said, or even just something you realized. Like, because it might not even been me that said anything. It might have been like, oh, I just realized something. You know, like I'm sort of curious.
But you definitely said something to trigger it, I would say.
Like, right. Like I'm sort of interested. So if you happen to have like the insight that worked for you, it may help someone else down the road.
Exactly. Yeah. I think personally for myself, Zach, what really like was my breakthrough moment was this. When I guess when you were like, draw a number line, just look at it and then know that I can just keep picking smaller and smaller epsilons to always get something to fit. That to me was like super crazy. Yeah. Skella shit says, I think actually getting the time to break it down with the number line, there was no time at university, it became a memory game. Yeah, so they were just memorizing things, Zach. And so like, if you have the time to like look at a number line and like look at it, you're like, oh.
I've been meaning to do this with the whole analysis curriculum anyway at some future day. So like, maybe maybe after differential equations I can go and.
Oh yeah, because you are developing a differential equation curriculum right now. That's what you're doing.
That's right. Yeah. I think I have too many things on my plate right now to really dig in, but I wonder if. With even the books that are out there, I still feel like there's stuff that can be done that's better to help people get into this stuff.
This is where, I don't know, maybe like putting this in some sort of like, I don't even know if you could put it in short form content. I think it would be really impressive if you could somehow have that breakthrough moment occur in like a 1 minute, 30 second like YouTube short.
90 seconds is a lot. Like,
right?
Like I don't know. I've got to figure that out. And there's that's easier said than done.
Right.
As I've come to learn, like I've been doing some video editing, and 2.5 hours, breaking that down to maybe 10 minutes is pretty hard in and of itself.
And
but
I feel like you got to break it down even faster in today's attention span. Like maybe you just like pick out like one little section of it. Like you have to distill like the instant like win that would help, and then like chain those wins in a couple little videos, I think.
yeah, I'll figure it out. I mean, at some point, this is all the kind of stuff I'd love to be able to do. I have finite time and infinite things to do, and
I know.
We know the time and money paradoxes of life.
Someone needs to figure out the cloning part, then we'd be okay.
Yeah. Or, as you might say, use ChatGPT, which I will not do.
No, you see, honestly, I'm, now that I kind of understand, now I'm curious to see what hot garbage ChatGPT was actually putting out for this question.
Well, so let's see what I mean, it probably gave something. It looks pretty reasonable as I'm staring at it.
This
like
was
it was very similar to what we were doing.
It did
just
do this,
chose
right?
It chose a poor epsilon for us, for our purposes. But
yes.
It chose a correct epsilon. But I think this is not as intuitive as what we saw on Stack Overflow, which speaks to the human versus the AI generated content. I think that this is not wrong, but it is it's not written for a human. It's not written
it's not
for
digestible.
somebody who's a novice. Yeah. And so I think that this choice of epsilon isn't that helpful.
Yeah.
For reasons I think we can see.
I think when I saw this, I think I asked chat like right away. I'm like, "Yo, dog! Like, how did you get that epsilon case?"
You should have said, "Yo, dog."
Well, let's see what it did. It said S squared is less than A, and we want to show that something's still in it. So that means S plus epsilon squared is less than A. So then it did this, right? And then it showed, oh, okay, so 2s epsilon plus epsilon squared is less than a minus s squared. The annoying term is the epsilon squared, right? So the standard trick is to force, epsilon squared is less than epsilon. So then you could say that, and then they factor. Oh, okay.
I see. Yeah. So that's a little bit better. It pulled the same 0 to 1 trick that we had before, and we choose the smaller of the two. That's the point, is that we want to guarantee that we're within 1, but we're also that the a minus s squared over 2s plus 1 is there as well. Just pick the smaller of the two so that we have both of those statements true at the same time.
Got it. Okay, that makes
sense. That's why you'll often see a minimum there, is because you want both statements to be true, so I can use the properties of both of those statements in my proof.
Yes, I see. Analysis is beautiful when it clicks. I agree. Yeah. Otherwise, it's
You're not that guy, pal.
It's a headache.
You're not that guy.
Oh my god. Okay, I think we got it. All right, I'm out of time. I really got to go. I just saw we did have 2 other questions that just got submitted. Austin and Dieps, don't worry. I'll still put these in our Discord, and if you come by on Thursday, I can go over them on the stream. Oh man, dude, someone gave me optics again. I don't want to do optics.
But is it a virtual image?
Oh my god, fucking optics. Okay. Anyways, yeah, Dieps, if you come by on Thursday, I'll do it. Austin, right. Okay, this is cool. This is linear algebra. This is not bad. But yeah, I do have to go. So, make sure go check out our Discord where you submitted the questions. Go click join our Discord, and any question we didn't get through today on the stream will get automatically put into there. And if no one gets to it in the next day or two, either ChatGPT will answer it, or I'll do it on Thursday's stream. Or you can go ask one of our other awesome math streamers who's doing things. Yeah. Okay, cool. All right, let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours. Big thank you to Zach for helping us out with real analysis. I appreciate you, Zach. Thank you for saving me. I know it's late for you too. This is like real late for you. It's almost 10 o'clock.
It's 9:40. Yeah, well, I'll be all right.
Okay.
I manage.
I appreciate it. I really do. Yeah. I appreciate all the questions. I appreciate all the help. I learn alongside you guys, which I think is the best way for knowledge to happen, rather than me just like lecturing. So this was really fun. when are you going to do your real analysis class again, Zach? When do you think you're going to do that?
Do you want me to? Because like I don't know
Like
how
over
I'm
the
gonna get
summer.
that done.
Yeah, maybe
Like
next
over the
year.
summer.
Next
I mean,
year.
look,
Next year. Next year. We can do next year.
I would love. I'd love to do that again. It was really fun when we did it in 2024. I remember we had a good group, and it would be good to get another round of it. But
Yeah.
Then I'd have some things to change. I think
Okay.
I have a lot that I'd do differently. But
let's
this conversation actually motivates some things that I'd like to.
Good.
Yeah. Anyway.
Yes, Skellshit loved it too. Yeah, awesome, Skellshit. You love the content? Love it. Thank you, Skell. This was worth staying up till 5 a.m. for, Dub.
Good for you. Well done for staying up so late.
Yes,
I'm impressed.
well done. Well done. Okay. Well, we're not going to make you stay up any longer. We're going to go raid someone. There's so many people on. I love this. So many people streaming these days. Who do I want to stream? Let's go see Astro. I haven't seen this guy in a minute. Cool. All right. Cool. All right. Thank you, everyone. There's no stream tomorrow, but we will be streaming again on Thursday. So enjoy the rest of your Tuesday. We will see you guys on Thursday. Peace. Thanks, Zach.
I think that's slightly contradicts everything.
Well, thank you. Thanks for having me on.
Holy potatoes. Jalopy, you're open.
Yeah, you guys are great. All right.
Actual education. How
Thank
we
you,
doing?
everyone, for being here on this momentous occasion.